We are continuing on with our Red Hat AI Combinator Hackathon code generation, and now we're going to do some smart device automation with the Fireware platform and the Smart Village platform. We have generated a complete set of APIs and web pages for photovoltaic measurement data. As you can see here, the API is here and the dashboard is here. Now we will build an OpenShift CustomResourceDefinition, CRD, an Ansible Role, and Ansible Playbooks to easily deploy photovoltaic measurement smart devices and register them as devices in the IoT Agent, update the entity data in the context broker, and send the same entity data to the Smart Village platform so that we can visualize it. So we need to install something called the Operator SDK, which is for building operators, and our operator is an Ansible operator. So we run this command and it'll install SDK. We just need to select bash as our kernel. Here it goes. Oh, something else I want to put in here is echo done. Oops. Echo done. So let's see. No such file or directory. Oh man. Do we have the operator SDK? Oh, we got it. So not a problem. Maybe it was already installed. Okay, so now an IoT agent expects entity data from all smart data models to be sent through a message broker like RabbitMQ. We install the Pika package so that it's a Python package so that messages can be sent to RabbitMQ to register new photovoltaic measurement smart devices and update smart device entity data. We install this with pip. And it's successfully installed. Now we reconfigure NGSI LD Smart Village Sync. It's a microservice that's currently deployed to this Smart Village web, but this one is running the Smart Village platform without photovoltaic measurement code. We want the one that is the VS Code develop, the one that we're currently developing, not this one. This is Smart Village. So we need to reconfigure our that service. When an IoT agent receives a message from RabbitMQ with identifiers that match a registered smart device, it sends the data to the context broker in NGSI LD format. After the context broker updates the entity data for the device in PostgreSQL, it looks if any services are subscribed to the entity. We configure all smart devices with a context broker subscription or webhook so that the context broker sends all entity data updates to the NGSI LD Smart Village Sync application we deployed in the project. NGSI LD Smart Village Sync application is configured to send subscription data straight to the Smart Village Platform API. We need to update our NGSI LD Smart Village Sync application to point to the new Smart Village application we started running in our OpenShift AI workbench for development. We run this and it'll update the Smart Village Sync with an updated host name, port, and SSL equals true. Now we define new automation for photovoltaic measurement in the Smart Village operator to make it easy to deploy photovoltaic measurement data at the edge like a real smart device. We create a new custom resource definition in our Smart Village operator and some Ansible tasks, roles, and playbooks to make it easy. The Smart Village operator gives you the choice to deploy smart devices as CRDs in OpenShift, or simply run Ansible playbooks pointed to the same YAML definition in a file instead of being managed by a pod in OpenShift. use the operator SDK to create a new CRD for photovoltaic measurement like this. So this uses the operator SDK and it's done. Now during code generation, we already generated the CRD schema for photovoltaic measurement automatically. We run the command below to observe the operator schema for the photovoltaic measurement here. This is what it looks like. And when the operator schema for photovoltaic measurement is already defined, run the command below to generate the Ansible Playbooks, roles, defaults, and more to complete the integration of photovoltaic measurement data into the Smart Village operator. So we run this. It's going to create some directories and write some playbooks and roles and defaults. And it's done. So now we get to do a really exciting part. We're going to deploy new photovoltaic measurement device shaped like a star on the map. Our Smart Village platform is ready to receive new photovoltaic measurement data in development, and our Smart Village operator is ready to configure new photovoltaic measurement smart devices in the NGSI LD supported fireware platform. Now it's time to create photovoltaic measurement devices and update their entity data. Run the command below to deploy a new photovoltaic measurement smart device named Star in the shape of a star on the map. Notice area served and name attributes below. Let me run this, and it's got an attribute of area served with coordinates in the shape of a star in the village of Eberron. And it's got a name of star. So this is subscribing to the IoT agent and setting up a new smart device. And then it's preparing a message to be sent on RabbitMQ to update the entity data. And it's done. So if we go to our development environment and click on photovoltaic measurement, it now has two photovoltaic measurements, and one of them is in the shape of a star. Isn't that cool? You can click on the star, and there's the star one, and it's got, oops, I zoomed way out. It's got a name of star. Okay, let's do this again. Let's deploy a new device shaped like a building on the map. So this one has a different area served that's a little simpler, and it's got a name of building. Notice that polygons in GeoJSON coordinates, there's 4 points to this polygon, but you always have to finish with the exact same coordinates as you started. So these are the exact same coordinates as where we started. So that's why there's 5 instead of 4 for 4 quarters. So we run the Ansible playbook and it's done. And now if we refresh, now we have a building and a star. So I hope that you can click on it, and we can build in more information here if we wanted to say more about this photovoltaic measurement. But this is a good start to a basic dashboard for our data. You can click on these and update additional fields. Set this to 100 or something, and it saves in the database. And if we refresh the page, then it's there. We can go back to here and we can click on API and see the data here. And there's multiple records here. It says found 3, returned 3. And there's a ton more you can do in this dashboard, searching the auto suggest or full text search, or filtering on fields like the name here. It says there's one called building and one called star and one called test2, or a whole bunch of other cool tools. but we won't go much into those. Stats like the max and the min alphabetically is building and test 2. There's 3. It does a lot more stats if you want to. But there's an idea of how this dashboard works. So I think that wraps up our course here. So this is the hackathon, and let's just review github.com/smartdevice/smart device API generation hackathon. I encourage you to take a look at what we've gone through, the overview, the technical details. We've talked through all of the technologies deployed and the AI ML tools and algorithms that we use that are based on Apache Solr and the Computate project. And we've run through all of these implementation steps together and saw the key features, how we generated thousands of lines of code, and the Ansible operators that allow us to so quickly deploy new smart data models, all the way through the platform, from the message broker, RabbitMQ, to the IoT Agent, to the context broker, to the NGSI LD Smart Village Sync, to the Smart Village platform for visualization. We can deploy new smart data models in less than 10 minutes. I was able to do this in 6 minutes and 54 seconds to build a new API and rebuild everything and have it working in development. So imagine having to write all this code yourself. It would take months or years, but we can do it in minutes. And that's a really powerful thing. So this vastly reduces the amount of software development and deployment and data import and data visualization that you have to do. We're going to now, there are some little things with the VS Code Maven Club plugin that I'd like to work out, but overall it works really well in the cloud. It's also possible to do this on your own computer with OpenShift Local installed. That's another way that I work with the Smart Village platform. But keep in mind that there's hundreds of FireWire smart data models that you can plug into this kind of solution and build them out with the Computate platform. And check out other examples of other projects I've built with the same technology for social innovation. You can check out computate.org for more details on the websites that I've deployed with these kind of projects, and the research that I'm up to, and the courses that I'm building that lets you that lets you work on this kind of technology together. So check that out as well. And I'm grateful to the Red Hat Social Innovation Program and the Red Hat research team who've helped me work on creative projects like this in open source over many years, and the Red Hat Build community who's sponsoring an upcoming hackathon with smart device technology at Shaw University in a couple weeks in North Carolina. And there you go. Try it out yourself with the VS Code plugin in OpenShift. And thanks for watching.